So this is just a summary of what's due up to this point, of what we should be looking to close out and cover and submit. We had chapter one, and chapter two's definitions initially. Then of course we have chapter one, chapter two homework in my math lab. Since we've done with chapter three, then we have chapter three's homework in my math lab, and also those four problems, that assignment one from chapter three. And then finally, we have that test from chapter one. And really, if I thought about it, I had the stuff, I would have put that, probably right here, closing out chapter one and two's assignments. All right. Any questions on that? So anything you haven't submitted to me, make sure you get to me. So we won't have a zero in my math lab or your, assignments, period.
I'm sorry, Professor.
Mm-hmm.
My audio and stuff was messing up, and I just got it working again, so I missed that small portion.
I was just saying these are the things that you guys are responsible for to this point.
All right, and so when will that all be due?
You just need to do it as soon as possible. Remember, we have a hard due date, and that's May. But really, if you want to stay on task, you want to try to do your best to keep up, with the lecture.
All right, gotcha. And it says homework and then my math lab.
That's the homework in my math lab.
Oh, okay, gotcha.
Yeah.
And then chapters. Okay, I gotcha.
All right.
All right, gotcha. Thank you.
Not a problem. All right. So 4.1, scatter diagrams and correlation. So you can ignore the 8.1, 8.3 red section right there. Probably used it for another section, another class. So it's 4.1 for us. All right, so scatter diagram is a graph that shows the relationship between two quantitative variables measured on the same individual. Each individual in the data set is represented by a point, and those points will be generated by the explanatory variable and the response variable. And we'll see what's the difference between the two in a second. Give you guys a chance to write that. As always, if I scroll up and you're still writing, let me know. All right, so here are the differences or the contrast between the explanatory variable and your response variable. Explanatory variable would explain the value of the response variable, while the response variable is explained by the explanatory variable. In other words, it will respond to the explanatory variable. And we'll see an example of that in a second. Explanatory variable is your x variables, response is your y. Explanatory is your domain, while the response is your range. Explanatory is input, response will be output. Then we have independent versus dependent, horizontal axis versus your vertical axis. And your explanatory variable is your predictor, while the response variable is your predicted. So you're going to try to, you will use your explanatory variable as a way to predict what the response variable will be. And that all will be based on previous observations. Here we have just a generic example of, how a scatter plot will look like, scatter diagram. Notice you go back to your algebra days when you had the graph on the XY, with an XY, on the XY plane, Cartesian coordinate plane. We have a horizontal axis, which is our explanatory variable, our vertical axis, which is our response variable. And notice we're only using the first quadrant. All right, linear relations. When a line best sums up the shape of the scatter plot, instead of having a linear relation. So here we have a few examples. See the first two. Show a scatter plot that has a linear relationship. The second two shows nonlinear. Now, just because it's not a linear relationship does not mean there is no relationship. So you see how we have an arc in the third example, then we have a wave in that fourth example. And then on that fifth one, that would be an example of no relation at all. Yeah, so that's what I said in the purple. Non-linear does not mean no relation, just no linear relation. All right, associations. Our points are positively associated when one value increases and the other, when one value increases, the other increases. So notice diagram down here, the dots or the points are going up. Then negatively associated or negative associations is when one value increases, the other decreases. And notice those points are going down. All right, next one's our linear correlation coefficient. It's a measure of strength and direction of the linear relation between two quantitative variables. So we can represent that correlation coefficient one or two ways. Remember, we talked about before how the population has different symbols than the sample. So the population correlation coefficient will be represented by Greek letter rho. Kind of looks like a P, but a little different. more smooth, I guess you would say, kind of like the Philadelphia Phillies, P in baseball. Um, but for the sample correlation coefficient, it's just the letter R, and that is the one we will use. We will use R, the sample correlation coefficient. Mhm. So going to that blue, it says find a calculator website, app, etc. that can produce the correlation coefficient and the regression line. So correlation coefficient is this section 4.1. Regression line is the 4.2. We haven't gotten there yet, but we will need something just like I mentioned before when we did standard deviation and the variance. You want something that can calculate that for you easily. Just like before I mentioned easycalculation.com. All right. Okay, properties of the correlation coefficient. First one is between -1 and 1 inclusive. If R is equal to +1, then a perfect positive linear relation exists. If R is equal to -1, then a perfect negative linear relation exists. All right. Number 4, the closer R is to +1, the stronger the evidence of a positive association. All right. Number 5, the closer R is to -1, the stronger the evidence of a negative association. And 6, if R is close to 0, then little or no evidence exists of a linear relation. And so R close to 0 does not imply no relation, just no linear relation, like we mentioned before. All right, last two. It is a unitless measure of association, and it is not resistant. So that means it is affected by outliers. Remember we talked about being resistant before Talked about how our median was resistant, but our mean was not resistant. And so your correlation coefficient is based on the calculation of your mean. So that's why it is affected by your outliers. All right, any questions before we scroll up? Make sure we're all right. All right, next, just have some generic examples of a scatter plot and what R could be in reference to those points. So straight line, R equal to 1. Notice how it's increasing though. So R is equal to positive 1. And then as we start to spread or our points start to move away from that straight line, you start to move away from that positive 1. So here we have 0.9. Here we have 0.4. Still have that linear relationship. It's just that it's moving further and further away from 1 and closer to 0 once you start to move away from that straight line. Same thing happens with your negative associations. R is equal to -1 is a perfect straight line. But then as you deviate away from that straight line, you start to move closer to 0. And then that last one, not having a relationship at all, a linear relationship at all, is also close to 0, R equal to close to 0. That second to last one, we had that arc again, but R would show that that would be close to 0. Once again, does not say there's no relation, just that there's no linear relation. All right. Questions? Any questions? All right. I think this is the last thing out of this section. So testing for a linear relation. Step 1, determine the absolute value of the correlation coefficient. Step 2, you want to find the critical value from table 2 in appendix A. And that will be based on your given sample size. Step 3, if the absolute value of the correlation coefficient is greater than the critical value, a linear relation exists between the two variables. Otherwise, no linear relation exists. All right. So our example here, determine whether a linear relation exists between the club head speed and the distance. So you're talking about a golf club or a golfer swinging a golf club, and the club head speed is how fast he's swinging that club, and then the distance is the how far the ball travels. So club head speed will be in miles per hour, distance will be in yards. And so our club head speed will be the explanatory variable, while our distance will be the response variable. So when you swing the club, the distance the ball travels is responding to how fast he's swinging the club, or the club head speed will explain, the distance that the ball travels. So here are our values. In other words, he swung the ball at 100 miles per hour, swung the club at 100 miles per hour. The ball went 257 yards. Swung it at 102 miles per hour. The ball went 264 yards, and so on. All right. Anybody still copying before we switch screens?
Okay.
All right. So, like I was mentioning before, you want to find something that will help you be able to calculate this. Remember, I said easycalculation.com is one. So I would type in easy calculation, correlation coefficient, and that would be the first one. And see, we have an X value, Y value. X is your explanatory, Y is your response. You can add columns, well, rows. You can even take them away if you have too many. All right, so let's type in these values. Okay. All right, so you type in your values, you hit calculate. And there is our correlation down here, 0.9386. And you always want to go back and make sure you check your values. Make sure you done everything correctly, because let's say if I take this 257 and change it to 256, all I did was mess up one number. Notice it changes my number completely down here. Now my number is completely different. Once again, change it back to 257. So one digit can change your correlation coefficient completely. So always go back and make sure that you calculate it. Not calculate, but inputted your values properly. All right, so questions on that. So if you're doing more than just typing in values and hitting enter, you're doing too much. There's a lot of things out there. Sometimes you have calculators where you plug it in, store it here, store it there, pull it back up. For have to put in a program. But there's plenty of free things out there that don't call for you to do anything but type in values and hit enter. So that's what you're looking for, something that will accurately calculate the correlation coefficient for you. Questions on that before we go back to the notes? All right. Also, while I'm here, let's go to the text. Took a little while, okay. So the chart that we're going to use, table 2, is going to be on A2, if I'm not mistaken. Yep, there it goes. All right, so let's go back to the notes. All right, so we found the correlation coefficient, which was step 1, and that was 0.939, excuse me. Step 2 is to take the absolute value of that. So don't forget, the correlation coefficient can be negative. Absolute value will ensure that you're dealing with the positive result. And that's what you want, or that's what they want, is for you to deal with just the positive result. And so that's why I say take the absolute value of your correlation coefficient. So the absolute value of 0.939 is still going to be 0.939. Then it says find the critical value from table 2, which is what I just showed, what we were going to see what a critical value is. And that's going to be in Appendix A on page A-2. So you saw what I did there. I went to the e-text, went to the box and typed in A-2, and it took me to this critical value chart that we need. So n is equal to 8. N is our sample size. How did I get that? If you go back here, each one of these is considered an observation. So it's not 16 numbers that we have here. We have actually 8 different times he swung the golf club. So we have 8 different times that, the ball traveled. So it's not 16 values, it's only 8. So make sure we're careful with that. So this is 1, 2, 3, 4, 5, 6, 7, and 8. All right. So that means n is equal to 8. So now if you go to the chart, and for n equal to 8, and I can't write on the screen, but you see for when n is equal to 8, the critical value is 0.707. If n was 27, the sample size was 27, then we were looking at 0.381. So whatever n is, whatever your sample size is, from 3 to 30, they give you a value for it. So we got 0.70 from the chart, 0.707 from the chart. Now for the fourth step, we compare the absolute value of the correlation coefficient and the critical value. Absolute value of R is 0.939. That critical value is 0.707. So the absolute value R is greater than the critical value. All right, questions before we go to the last step? So the conclusion, since the absolute value of R is greater than the critical value, then a linear relation exists between the club head speed and the distance. So if the absolute value of R was not greater than the critical value, there would not be a linear relation. All right, questions on that process, questions on anything we talked about so far. All right. So, this section is the only section we're going to do today. That's how I did in last class, so I'll just hold true to that. We'll look at 4.2 and 4.3 on next class. The reason why I'm not continuing on because I just went through the list of the things you guys have to do, and I'm trying not to go too fast. Try to give you guys a chance to get this stuff done without having more stuff just piled on top of you. So don't forget also, well, I won't say don't forget. I don't know if you have looked ahead. There's only 3 sections in chapter 4. So that's why it's important that you knock out this stuff while it's easy. If all we're doing is definitions, chapter 1, chapter 2, you go ahead and knock the stuff out so it's not sitting around when you still have stuff being given to you as information. So soon we'll be done with chapter 4. And like I said, I'm gonna do my best to pull up, or not go as fast as of course we could. So next class I know we do 4.2, 4.3, and then what we'll probably do is the class following a review day, see where everybody is, see if anybody have any questions, stuff like that, before we jump into another chapter. So give you guys a chance to ask questions, and give you a chance to get the stuff done, like I mentioned before. So before we close out today, questions, concerns, comments, anything, anybody? All right. So if you guys are good, I am good. Like I said, that's it for today. Today's Wednesday, right? Yep. So have a great weekend. Be safe. And I will see you on Monday. Don't forget, if you have any questions, feel free to shoot me that email and I will respond accordingly. But you guys have a great day.
Thank you. Have a great day.
Thanks. You the same.
Bye.
Bye. Take care.